So this video is like an introduction to the statistics side of the psychology A level, and this is only A level that this is required, which requires you to understand levels of significance within psychology and which ones we use when we're writing up results, and also type 1 and type 2 errors, and then just introducing to you what the statistical tests available are. If you look at the first slide on the board, you should have seen this throughout your psychology lessons. When we're writing up results, the ideal that every psychologist aims for is to be able to say that the probability of the results being down to chance is less than 0.05, which basically means that the probability of the results being down to chance is less than 5%. So that translates to the fact that we are 95% sure then that our results are down to the fact that the IV has had a direct cause and effect on the DV. And that's obviously what we're trying to prove with an experiment, that one thing can cause an effect onto something else. Now, if we can do that within psychology, we would say that our results are statistically significant. We're 95% sure that our results are down to a cause and effect relationship, and that's what we're aiming for. Now, we can, of course, change this level, and you might see this within your exam papers or within pieces of research that are written up by other people. So you might have a set of results listed as p is less than 0.1, and obviously that means then that the probability of the results being down to chance is less than 10%. So we're only 90% sure that our results are down to a cause and effect relationship between the IV and the DV. You might also see where the probability, or p, is less than 0.01, which is obviously a situation where we've got a 1% chance that the results are down to chance. Now that therefore means that we're 99% sure that the IV has had an effect on the DV. So we're obviously much more confident within a statistical level like that. Now, as I just discussed on the previous slide, we can have situations where we're accepting the probability of our results being down to chance as 10%, 1% or 5%. And as a result of this, it can lead to either type 1 or type 2 errors. Now, a type 1 error is also known as a false positive because we're saying there is something there when there can't be. So, for example, we would be accepting our experimental hypothesis and rejecting our null hypothesis and saying that there was a relationship between the IV and the DV in a certain experiment, when in fact there wasn't. Now, this often happens when we're using a probability level that's too high. So, for example, if we've got p is less than 0.1, then there's a 10% chance there that our results are down to error or they're down to chance, and we're only 90% sure that there was a relationship. And in those situations, if a psychologist has got those results and has therefore accepted the experimental hypothesis, a type 1 error can occur when in fact there wasn't a relationship between the IV and the DV. A type 2 error on the right hand side of the page is the exact opposite, and that's why we call this a false negative. So this, for example, is when we're saying there isn't a difference or a relationship between the IV and the DV, when in fact there is. So in this situation, we've accepted our null hypothesis and said there's no difference and rejected our experimental hypothesis, when in fact, actually, we've been a bit too strict. Because a type 2 error will happen in a situation where we're using our probability level as, say, 1%, so p is less than 0.01, in which case we're saying that we're 1% sure that the results are down to chance, and 99% sure that there was a relationship, but then we've rejected the experimental hypothesis. So we're saying there wasn't a difference when in fact there was, because we've been a bit too strict. There's quite a nice table on the video now if you want to pause and just kind of refresh the information that I've just said and see how we would explain this or we would write this down. Moving on now to types of data. Now there are 3 levels of measurement, which is also known as types of data, that you are required to understand within your exam, and they're nominal, ordinal and interval. I've put here interval/ratio because the Edexcel specification that I focus on doesn't require you to understand the difference between the two. Now, nominal data is a situation where we've got separate categories. So you might have blonde hair, you might have brunette hair, you might have red hair, you might have black hair. You would be put into a certain set of categories. That would be an example of nominal data. Ordinal data is exactly like it sounds. It's any sort of data where we can order it. So, for example, you might have happiness scales on a Likert scale. You know, how happy are you feeling today between 1 and 7? 7 is the happiest you've ever felt before in your life. Everybody would therefore have a numerical measure of how they feel. And because we can put those in order, we would say that that was ordinal data. Now, interval and ratio, this is basically a situation where the level of measurement that you're using has equal measurements between them. So, for example, things like time, the amount of minutes it took somebody to do something, the amount of kilograms somebody weighs, the amount of words that were recalled. Because the distance or the space in between the intervals or the space in between the things that we're measuring is consistent and exactly the same all the time, then we would say it's interval data. I appreciate that I said you don't need to know this, but just for your own information, the difference itself between interval and ratio is simply that ratio has a 0. So for example, you can have a 0 time. It can take you no seconds whatsoever to achieve something or whatever. But again, it doesn't matter necessarily for that within your exam. For you, if you've got anything with an equal measurement between, we would say it's either interval or ratio data. Now, these 3 different levels of measurement are particularly important within psychology, but they're also really important for you when you're choosing which inferential statistic that you need to apply in a certain situation. So for example, if you look across the board, you will see here that we've got our experimental designs here, which we should know already. So we've got our independent measures design or our repeated measures design, which literally refers to how we've used the participants. So whether we've got separate groups of participants doing separate things, or whether within a repeated measurements, we've got one group of participants who may be doing more than one condition. There's a separate video on that if you need to revise those. And then you can see here on a correlational design, again, it is a separate video, but this is when we haven't got an IV and a DV that's being manipulated. We've actually got covariables and we're looking for the relationship between them. Now, once you've decided whether a piece of research is using independent measures, repeated measures, or correlational designs, you will see down this side, you then need to make a decision about whether the data collected within that particular experiment was nominal, so categories, or ordinal or interval. And the reason they're grouped together is because we don't differentiate between them. Now here, for example, say you were doing or you were asked to suggest which statistical test should be used for a piece of research that used a repeated measures design, for example, and collected nominal data, you would simply go across here and you would be able to say, right, okay, that's the sign design. Now, interestingly, on your spec, and I do appreciate this is confusing, you don't actually need to know how to do the sign design. You just need to be able to do chi-squared, which you will see here is used whenever we've got nominal data, or Mann-Whitney and Spearman's rank, and Wilcoxon, sorry. Now, the difference between Mann-Whitney and Wilcoxon is simply independent or repeated measures. That's it. And there is a separate thing on that within the videos to help you to decipher between those. And then again, if you've got any sort of correlational design that's collecting ordinal data, that would be Spearman's as well. I do appreciate that this is quite a confusing table, but unfortunately you do need to know this, and you need to know this off by heart. In your exam, you could be given a certain situation and asked to suggest which statistical test should be used because you've deciphered the experimental design and the type of data, or you might be given the statistical test that you need to do and asked to complete it. So it is really important that you understand this bit. Again, here I'm just reminding you where you will have learnt about these different tests within your specification of year 12 so that you know exactly where to go and get your notes and revise from. So within social psychology, you looked at standard deviation. We also looked at measures of central tendency there, so mean, median, mode. But we also started to look at measures of dispersion, of which standard deviation and the range are examples, and they are videos of those on the YouTube channel. Within cognitive psychology, we learned about Mann-Whitney-U, and then we also did the Wilcoxon sign test. Please don't forget the only difference between those two is that it's independent measures or repeated measures. Within biological psychology, our focus there obviously was correlations. So our statistical test within biological psychology was Spearman's, which remember we only ever use if we've got a correlational design. And then within the learning approaches when we did the chi-squared.